All right, we're going to begin a unit on properties of logarithms. The point of properties of logarithms is to make your life more simple. So there's not really one way you can apply a property. You just kind of have to think, what's going to make my equation more simple, or what am I make my term a little more simple. So the three properties are the product property, the quotient property, and the power property. And all of these properties can be applied in both directions. The most important thing about the properties of logarithms is to remember that the word log means exponent. If you remember that the word log means exponent, then all you're doing is following the properties of exponents. So just remember that log means exponent. So the product property says, let me get rid of that thing there. So the product property says that we have logs being added together. If you remember, the word log means exponent. What this is saying is that we have log plus log. Or in other words, we're adding exponents. When you add exponents, you're multiplying. So that's exactly what we're going to do with the logs. We're going to multiply. But we're not going to multiply everything. We're only going to multiply the of portion. Notice a couple of things about these logs. The bases are the same. So what this is saying is take the 4 and the 9 and multiply them together and put it in terms of one log. This is still log base 2. The base is not changing. Only the of portion changes for properties of logs. And 4 times 2 is 36. Now this is asking you 2 to what power is 36? So if we wanted to solve this expression and say, what is this equal to? 2 to what power equals 36? Okay, that's what this is asking you. However, there is no exponent of 2 that would give you 36. No integer exponent. We'll find out how to solve this at a later time. For now, we can leave this like that. Okay? So this is if you're adding logs together, you can combine them and make them one log. Conversely, if we have one log, we can make it many logs. So we have log base 4 of 3xy. We can expand that into the sum of logs. Now these things are being multiplied together here. 3xy are all being multiplied. What are we multiplying? We're multiplying exponents, right? So when you multiply with exponents, you add the exponents. That's what we're going to do with the logs. We're going to add these three terms together. Notice the base is 4, so all of the bases will be 4. Then you say, how many terms are being multiplied together? There are 3 terms being multiplied together here. So there'll be 3 logs being added together. It'll be log base 4 of 3 plus log base 4 of x plus log base 4 of y. So we have 3 things being multiplied together, so we have 3 logs being added together. The word log means exponent. When you're adding exponents, you're multiplying terms. Okay, now there's the quotient property. The quotient property is, again, just a property of an exponent. So you have to think to yourself, what do I do when I divide? What do I do to the exponents? You subtract them. That's exactly what we're going to do with the log term. So if we're subtracting logs, that means we're subtracting exponents. When do you subtract exponents? When you divide. That is why it's called the quotient property. So let's just clean this up. We have log base 2 of 16 minus log base 2 of 4. So we're subtracting logs. That means we're going to divide the of portion. We're going to divide these 2 numbers and make it one log. The point of the properties is to either make many logs one log or one log many logs. So log base 2, and we're going to put this in terms of one logarithm of 16 divided by 4. 4. So now what this is saying is 2 to what power is 4? 2. Let's think about this another way. So this expression is all equal to 2. Let's do this a different way. This says 2 to what power is 16? 4. 2 to the 4th power is 16. Therefore, log base 2 of 16 is 4. Also, this is saying 2 to what power is 4? Well, 2 to the 2nd power is 4. So 4 minus 2 is 2. Same exact thing. We didn't even have to apply properties of logs to clean this thing up, because we knew 2 to what power is 16, and we knew 2 to what power is 4, and we could just combine those terms. However, the direction is here to ask, express it as a single logarithm. So that's exactly what we're going to do. 16 minus logs, subtracting exponents, dividing. Those are the 2 numbers that we're going to divide. So log base 2 of 16 divided by 4, which is log base 2 of 4, and that is equal to 2. All right, now we could also make one log many logs by applying a property. So you have to think to yourself, what's happening with the of portion of the log? The of portion of the log, we're dividing. So you have to think the word log means exponent. We're dividing. What do you do when you divide? You subtract exponents. So that's what we're going to do with this log. We're going to subtract logs. We're going to subtract exponents. The base will remain the same, log base 4. And the numerator comes first in a subtraction, just like if you're simplifying terms. Log base 4 of x minus log base 4 of z. And there we go, subtracting exponents because we were dividing. The last property is the power property. Now, again, these are the properties of exponents. You have to think, the word log means exponent. We're multiplying an exponent. When do you multiply exponents together? When you're raising a power to a power. So the product property, the power property says you can take exponents and make them coefficients and make them exponents. Or you could take exponents and make them coefficients. Either way, depends on what you're trying to do. So in this case, we could say log base 2 of 4 squared minus log base 2 of 4. Well, 4 squared is 16. So log base 2 of 16 minus log base 2 of 4. We're not done yet because they asked us to express it as a single logarithm. So we're subtracting here. We're subtracting what? We're subtracting exponents. You're subtracting exponents when you divide. So that's what we're going to do with our ofs. We're going to divide the of portion of the logs. We're going to divide these two numbers and express it as a single logarithm. Log base 2 of 16 divided by 4 is 4. Now we can clean this up because this is 2 to what power equals 4? Again, 2. Let's think about this another way. Let's evaluate each of these terms separately. Now keep in mind, we got 2 there. So let's see if we get the same thing, just to make sure we're applying the properties correctly. I could say, what is log base 2 of 4? I know that this term right here, log base 2 of 4, says 2 to what power is 4? 2. I still have a 2 there, so 2 times 2. Minus, well, log base 2 of 4 again. So log base 2 of 4 is 2. 2 times 2 is 4. 4 minus 2 is 2. Same thing. Another way we can think about it is that we have a common factor of log base 2. So we can say log base 2 of 4 times, after we factor this out, we're left with 2 minus 1. Well, 2 minus 1 is 1. So log base 2 of 4 is saying 2 to what power is 4? 2. The third way we got 2. Let's think about this another way. We have 2 log base 2 of 4 minus 1 log base 2 of 4. If you take a look at this, this is just like 2x minus x. Well, 2x minus x is x. Therefore, 2 log base 2 of 4 minus log base 2 of 4 is 1 log base 2 of 4. Again, 2 to what power is 4? 2. 4 ways we got the same exact answer simply by applying properties of logarithms. The last example here says expand this logarithm. Now, we have a 1/2 in front of here. So we can expand all this and then leave a 1/2 in front. I'm going to do this a couple of ways as well. So we have a product here, 3 times x times y. Since we're multiplying and we're using exponents, that means we're going to add the exponents. In this case, we're not going to add the exponents, we're going to add the logs. We have 3 things being multiplied together, so we're going to have 3 things being added. So let's rewrite this as 1/2 times all of this. Log base 4 of 3 plus log base 4 of x plus log base 4 of y. I can distribute these 1/2 to all of my terms and say 1/2 log base 4 of 3 plus 1/2 log base 4 of x plus 1/2 log base 4 of y. Let me move this up in case you're having trouble seeing that. So what I did, I expanded all the logarithms with plus signs, plus, plus, and then I distributed the 1/2 to all 3 terms. So now each term has a coefficient of 1/2. Last thing I have to do is make these coefficients exponents. So now this is log base 4 of 3 to the 1/2 power. But I know what 1/2 power means. 1/2 power is power over root. So really this is asking me to take the square root of the of portion. So my final answer is going to be log base 4 of radical 3 plus log base 4 of radical x plus log base 4 of radical y. Okay, let's think about this another way. Try that again. So, what we have is a 1/2 in front of these things. What I can do is bring the 1/2 in front of everything. And I could say log base 4 of 3xy all being raised to the 1/2 power. I could apply the power property immediately and not necessarily the product property right away. So if I apply the power property immediately, this says that 3 is being raised to the 1/2 power, x is being raised to the 1/2 power, and y are all being raised to the 1/2 power. So I'm going to raise them to the 1/2 power separately. Log base 4 of 3 to the 1/2, x to the 1/2, y to the 1/2. And now I can apply the power property because I'm multiplying numbers together. If I'm multiplying the of portion, remember, when you're working with multiplication and exponents, you add the exponents. So we're going to add the logs because log means exponent. So let's rewrite this as not LG, log base 4 of 3 to the 1/2 power. But I know what 1/2 power means. That's power over root, so that's radical 3 plus log base 4 of power over root, radical x, plus log base 4 of power over root, radical y. So those are the properties of logs. We're going to continue practicing these things because there's no way we can solve a log equation until we're comfortable with these properties. So what we're going to do over the next day is practice expand from one log to many logs and from many logs to one log using more than one property within the same approach. So as we begin practicing these properties, it will become that much easier to solve equations, which is where we're going with it next time.